Growing up, school trains you to expect that every question has a neat, predetermined answer, just waiting to be memorized and recited. But true science begins where textbooks end. Out on the frontiers of physics and cosmology, we focus on questions where the answers are currently unknown. It is here that we run into epistemological paradoxes. This visualization shows a massive weight of mathematical probability directly opposing an empty scale of observable physical reality. The math tells us one thing is virtually certain, while our eyes tell us the exact opposite. This friction is where modern physics currently lives. We are caught in the gap between what equations predict and what we can actually touch. The deepest mysteries of our existence currently hang suspended between two impossible numbers, 0 and infinity. To grasp the scale of our observable reality, consider that you could fit 1 million Earths inside the sun. And yet, the sun is just a tiny pinprick, one of roughly 400 billion stars swirling inside the Milky Way galaxy. Even with hundreds of billions of galaxies out there, we hit a physical wall. Space itself is expanding at an accelerating pace. The vast majority of galaxies are rushing away from us so fast that their light will permanently fail to reach our telescopes. To map this expanding architecture, physicists like Stephen Hawking turned to mathematical frameworks like string theory to explain the underlying laws of the cosmos. This chart compares atoms in our universe to 10 to the 500th power, the universes predicted by string theory. Quantum mechanics complicates this further. The math suggests parallel realities are splitting every single moment based on quantum outcomes, creating an endlessly expanding fractal. The highest levels of theoretical physics demand infinite realities, yet human observation is permanently locked into just one. This infinite math crashes into a biological contradiction. If the universe is infinitely vast and constantly expanding, where is everybody? Physicist Enrico Fermi famously posed this exact question in 1950, pointing out the terrifying silence of the cosmos. This map plots Kepler data. The Milky Way holds 500 billion planets, leaving 50 million potentially life-harboring worlds. The timeline deepens the contradiction. Earth formed 9 billion years after the Big Bang, giving other habitable worlds a massive billion-year head start. There are some deeply unsettling explanations for this silence. A superintelligent apex predator civilization might be enforcing strict radio silence to eliminate competitors. Or the ability to create sophisticated technology universally leads a civilization to destroy itself before it can reach the stars. Early civilizations build massive machinery that is easy to detect. Advanced intelligence, however, evolves past giant physical artifacts. Just as stereo cabinets shrank into pocket-sized devices, an advanced species might reduce its footprint entirely, retreating to a microscopic level we simply cannot detect. Statistically, the conditions for life are scattered throughout our galaxy in the millions, yet our physical observation remains stuck at 0. This uncertainty isn't a failure of science. We are a remarkably young civilization, and living with these questions is the defining characteristic of a species that is just beginning to open its eyes. We are actively building the tools to bridge the gap. Arrays of satellite dishes are currently gathering vast amounts of public SETI data, and new atmospheric spectroscopy techniques are scanning nearby exoplanets. We are hunting for the physical evidence to match the math. Whatever the ultimate truth is, the implications carry massive weight. We are either surrounded by an infinite microscopic web of quantum realities teeming with neighbors, or we bear the profound, singular responsibility of being entirely alone in the void. The friction between what mathematics predicts and what human eyes can observe is the engine of our curiosity. It is the very force pulling us forward into the dark, demanding that we keep looking.